Hi guys, today is day 30. We are looking at lesson 78. And today we're looking at graphing inequalities. So again, inequality greater than, less than, and how we graph those is just on a number line. So the different symbols we have, greater than or less than, or if they have the line beneath them, then it's greater than or equal to. That's what that line below means. Or obviously less than or equal to. We have 4 different symbols that we use. We've worked plenty with the equal sign, so 5 different symbols when we're comparing 2 values. So the value on the left and the right, they could be equal to each other. It could be greater than or less than. If we're talking about a range of numbers, it can be greater than or equal to, or less than or equal to as well. Okay, and how we graph them depends on what we're looking at. So these are inequalities. We're going to have more than one number that satisfies them. We'll take a look at this. So if I have x is less than or equal to 4, okay, well, x is less than or equal to 4. So let's just go ahead and make our number line. Let's take a little bit past, and we'll take it super far. We got 4 on there. It's less than or equal to. So it's less than or equal to. So I use a shaded circle, because if I put in 4 for x, x is less than or equal to 4. It's equal to 4. So it would include this. If this line wasn't there, then I would use an open circle, and you'll see an example of that. And then it's less than, so 3 is less than 4, 2 is less than 1, 0, and continuing on to negative infinity. So all the values to the left would be true. That's what we said. We're talking about a range of numbers. So I could plug in 0 for x. 0 is less than or equal to 4. True. I could put in negative 100. Negative 100 is less than or equal to 4. That's true. So there's going to be more than one solution. That's where we just said x equals 4. We just plug in a dot above 4. X is equal to 4. This is less than or equal to. So it's going to be more than one solution. It's actually going to be infinite numbers. It could be 3.9, 3.5, 3 and 1/10, 2.5, 1. I mean, it doesn't even just have to be integers unless the problem says it has to be integers. Oops, we're graphing on the line. It's solid. It goes that way. Now, if we have x is greater than 4, again, greater tells us we're going to be going to the right, and then no line below tells us that it's going to be an open circle right there. Because if we put in 4 for x, 4 is not greater than 4. That is not true. So it doesn't include 4, but it does include everything to the right. That includes 4.00001. Barely bigger than 4, but it's still bigger than 4. 4.2, 4.3, 4.4, and 5, 6, 7, 8, 9, continuing on. So again, all of those numbers, not including 4, but to the right of 4, all the way to positive infinity, would include that. Okay. And we'll go over these examples. We'll look at down the road problems where we're solving inequalities, isolating a variable, just like we do with an equal sign, but looks like for these ones today, we'll just be graphing. So just do your number line, pay attention to which direction the sign is facing, and then whether it has this line beneath it, whether it's going to be a shaded dot. So if a line is below it, it's going to be a shaded dot. If there is no line, then it's going to be an open circle above whatever number it will be. Okay. All right, we will get 79 and 80 left to go. But that is all we have for today. So see you guys in class.